Hi doctors, today we will discuss about more dimensional formulas and how they are going to get problems and mainly uses of dimensional analysis and homogeneity principle. How much possibility is there we will see depending on that. So what are the uses of those dimensional formulas? We have written some dimensional formulas. What are the uses for that? In that, so one of the use I am going to say to check the correctness of the equation. To check the correctness of the given equation. If any equation you people came to know that equation correct or not, you are going to cross check. So for this, sometimes you require homogeneity principle. So what is that homogeneity principle? If z is equal to, if you are doing x plus 5, if z is equal to, if you are doing x minus y, if you want to add two physical quantities, here x and y are two physical quantities. If you want to subtract two physical quantities, so those two physical quantities should have same dimensions. What they should have? They should have same dimensions. Means to add or to subtract, you require same dimensions. Then only you can write in between plus or minus. For multiplication and division, you do not require same dimensions. So what is the example for this? What is the example for this means? Everyone came to know this formula. V is equal to U plus AT. Everyone came to know? V is equal to U plus AT. Now follow this rule. What is homogeneity principle is saying? Same dimensions can be added. At the time x is equal to y dimensionally, like that z is equal to x and z equal to y. Here also same. Z equal to x, z equal to y. Means dimensionally x is equal to y, dimensionally z is equal to x, dimensionally z is also going to be equal to y. I am not saying about physical quantities are same. I am saying about dimensionally those are equal. How that dimensionally equal means, coming to here. So here u is initial velocity, v is final velocity, at product of acceleration and time. Acceleration into time if you do means how much dimension you are getting, velocity dimensional also we are going to get, all are here equal. V is equal to u, correct? What is velocity dimension formula? If it is initial or final, velocity dimension formula is LT power minus 1. Now both are same. Now I told you V is equal to AT, U equal to also AT I said. Any one if you prove, that is enough. Now we will see what is U dimension formula. We said LT power minus 1. Now AT also you should get same. We will see. What is acceleration dimensional formula? L t power minus 2 into t. What you got? L t power minus 1. Now, if you are adding u and at means these two are having same dimensions. So, therefore, v is equal to u equal to at according to same dimensions. So, this one is going to be giving information from homogeneity principle. So, you can take any other equation. You came to know this equation after that. S is equal to ut plus of at square. Now, see here between ut and half at square, what you wrote here? Plus. Like that, s equal to ut. Like that, s equal to at square. Like that, ut equal to at square. Now we will see. What is s here? Displacement. Displacement dimension formula? Length. L. ut. What is u I said? Initial velocity. Velocity dimension formula? Lt power minus 1. So t is nothing but time. That is also L. ut is also L. Now half at square. Half at square, half is constant. We won't write dimension formula for that. A means acceleration, Lt power minus 2. T means t square. Again you got L. So therefore here S equal to ut dimensionally, ut equal to half at square dimensionally, like same like that, S equal to half at square dimensionally, all these are going to be equal. That is the meaning of homogeneity principle. by applying this homogeneity principle, you will get so many problems in our NEET exam. So we will cross check one or two problems on that in today's session. Now, can we add acceleration and time? Can we add acceleration and time? We cannot add. Why? Because acceleration is dimensional formula LT power minus 2, time is t. So this is having different dimensions, this is having different dimensions. Therefore, you cannot add acceleration and time according to dimensional formula. Sometimes they will ask this question in exam. These two are different means you cannot add. If these two are same physical quantities, then you can add those physical quantities. Okay. Now, see one example how to check the correctness of the equation. So, force F is equal to m v square r I gave. What is m means here? Mass of the body. What is v means here? Velocity of the object or body. R is nothing but radius, I am saying. Then is this equation correct or wrong? I have to cross check. So we are using to check the correctness of the equation. So for that I have taken one example. Now for this how we have to solve means, first we have to take LHS. What is LHS here? Force. What is force dimension formula? I told you to remember mLT power minus 2. So if you call 2 to 3 times, you can remember force is mLT power minus 2. Now we have to consider RHS. Now what is the RHS? M V square R. So what is M? Mass dimensional formula. M. What is velocity dimensional formula? LT power minus. What is radius dimension formula? Radius equal to length. Therefore, if you have done this, M L square T power minus 2 L. So M L cube T power minus 2. Now see LHS equation number 1. Now see RHS equation number 2. Both are same. So this is ml t power minus 2, this is ml cube t power minus 2. So equation 1 not equal to equation 2. Therefore this equation is going to be wrong. mv square r. So to check this equation, we have used dimensional formulas. This is the first use of dimensional analysis. Like this, how many number of equations are giving? We can check whether those equations are correct or wrong. So let us assume v square minus u square equal to 2as. Now see here, in between these two what is there? Minus is there. So here LHS should be equal to RHS. So you should not subtract the dimensions. Here v square minus u square means dimension of velocity square. So dimensionally v square minus u square should be equal to LT power minus 1 whole square minus LT power minus 1 whole square. Both are same means this minus this 0 you cannot apply. So this LT power minus 1 whole square, LT power minus 1 whole square is dimensionally equal to LT power minus 1 whole square. So this v square minus u square equal to dimensionally LT power minus 1 whole square. That is nothing but L square T power minus 2. This is LHS for this equation. So RHS, 2as, 2 is constant. What is acceleration dimensional formula? L T power minus 2. What is distance of displacement dimensional formula? L. So L square T power minus 2. So this one and this one dimensionally equal we are going to say. Even for the last previous equation also. So V is LT power minus 1. U is LT power minus 1. AT also you will get LT power minus 1. So here you cannot add these two. So dimensionally these two are equal to LT power minus 1. So this is LT power minus 1. Like this we have to check whether equation is correct or wrong. Okay. Now I am giving another equation. Force is equal to momentum into time. Is this equation correct or wrong? Can we check? So force dimension formula mLT power minus 2. This is LHS. What is momentum dimension formula? Momentum dimension formula mLT power minus 1. If you want means you can write here. Momentum means product of mass and velocity. So mass is m, velocity is LT power minus 1. So t is here time. Therefore, ml t power minus 1 t power 1. 1 minus 1 0. So right side you are getting ml, left side you are getting ml t power minus 2. Therefore, this equation is going to be wrong, isn't it? So like this we are going to cross check whether the given equation is wrong or correct. So m equal to f by a, same equation, the small change I am giving, everyone came to know for us this one is correct or wrong. M is mass, m. RHS, what is force dimension formula? mLt power minus 2. What is acceleration dimension formula? Lt power minus 2. You both got cancelled, what you got? RHS. So LHS also m, RHS also m. Therefore, this equation is correct. Just this equation f equal to ma, everyone came to know. Therefore, I have given this equation only like this I get, isn't it? So to cross check, you can take some known equations. Those you are going to get fastly and you are going to get practice also. So this is to check the correctness of the equation by using dimensional formulas. So force dimension formula, momentum, time dimension formula. Like this we have substituted. So next take any other equation. So what we can take means impulse. Impulse is going to be, or simple one only you can take. Otherwise, if you don't know impulse, you cannot get the answer. So momentum. So momentum is equal to force into time I rho. Here force equal to momentum into time I rho. So is this equation correct or wrong? We will cross check. What is momentum dimension formula? mLt power minus 1. What is force dimension formula? mLt power minus 2. Time dimension formula t. So t minus 2. So mLt power minus 1, mLt power minus 1. So both are going to be equal. Therefore, this equation is going to be correct equation. So like this we are going to cross check. Even time period is equal to 2 pi root L by G. Is this equation correct or wrong? Time period means time, dimension formula t. 2 pi is constant, leave that. L by length means L, G acceleration due to gravity, L t power minus 2. 1 L will be cancelled, t power minus 2 going to numerator. What it is going to return? T square. Root t square means it is going to be t. Therefore, LHS equal to RHS. This equation is going to be correct. So like that you can cross check how many equations we have known. You are going to get idea. So in next video we are going to discuss about homogeneity principle, how we are going to solve. So like this concept wise we will go. Even the video is less time, you can practice after this completion of the video by your own, then definitely you are going to get more problems very easily. Thank you.